Hey folks, today we're going to do Memory Game, the second battle of Road to Las Vegas in 2026. We're going to try it without using any lambdas or macros. Ready, set, go. Okay, so we have this grid here. I'll name this map. And let's build a table around that, a flattened values table. So address is going to be to call address row map, column map. Yeah, we're blocking. You're blocking me, timer. 4 to remove the dollar signs. There we go. Value is going to be just to call map. And row. Oops. It's going to be map our map, return the row. Call. And the same thing for column. Change the function to column. And normally I stop there, but here we also have this table matching values to names. So just put name there as well. Do the next lookup. Like so. I'll copy paste values and turn this into a table. Call it T. Oh, sorry, I don't like T. I like M. Okay. I think we're good to start answering questions now. How many times is symbol on the grid? So this is just COUNTIF map inner value. Okay, what symbols appear? So this is the value of having that table without any lambdas. I can just look up the address. Like that. No indirects. So it doesn't slow me down. Alright. Here, if both cards match, player scores a point. So it's just one player. So we're going to say sum by call. We're going to wrap calls to turn this into sets of 2. So lambda C. So in our column, if index C1 equals index C2, well then that's a match. Is that all we have to do? Yep. Alright. When looking at the grid from top to bottom, so our map already has this. Top row to the bottom row. Where can you find this? Alright, so we just have to do X match, or X lookup, sorry. This in mname, it'll find the first one and return the row. Okay, one player game, subsection. Okay. Here I'm gonna use indirect because I don't have any lambdas to help me. So we'll just do this grid. That should give me those. Okay. So we'll put those into a column and then say let T for temporary be those. We'll group by TT count A 0 0. That should get our counts. Let's just take the first column there, or the second column, sorry, and then do a quotient. 2 and sum those up to get our matches. Okay. And then I'll copy and paste these values. I have the formula here, but I don't want to have them keep recalculating. Alright, level 6. This is a 2-player game. So I will make a data table on this one, I think. So I'll just come out to the side here. And and this is in my way. Okay. So that's where the game numbers go. We'll say XLOOKUP this here and return. Let's see how I'm going to select from here over. I think that should be good. Okay. Nice. So in this one, the first two are lucky symbols, and then the cards start at the third value. So we will say, let's filter this where it's not 0, and then we can drop the first two values, and then we'll wrap calls to bring them into pairs. Okay, so let's go one step further. Choose rows 1 and 2, so I can cleanly reference each row. Okay, so we can say equals that would be a match. So those are matches, and now we have to find out which player is playing. So it starts with player 1, but if he gets a match, he keeps playing. So we'll say equals scan, starting from player 1. Then we'll just take all but the last one here. So drop -1 lambda AV. So we'll say if v equals 1, then the player stays the same. Otherwise, swap players by doing 3 minus a. Yep. That should give us one short, and then we'll H stack our starting player to that. So let's see if that's good. So we start on player 1, it repeats because there's a match here. Yeah, I think we're good. So now we have to track cumulative score. P1 score, and it'll be a scan. We'll need an index, I think, a sequence. Yep. Okay, so what's the logic for the score? It's gonna be if this is player 1, so if index of our player equals 1, then we can count our score. So it'll be A plus, did we score a match? Yep. Times if index of this equals our lucky symbol anchored. Let's see, do I need an extra parenthesis here? Yes. Times index, the second set should also equal that. So I did that wrong. Yes. Equals that. Okay, so if both of those are true, then multiply by 2, otherwise multiply by 1. I feel like I got my parentheses botched here. Let's check it out. Because this one, where am I? Okay, we're good. If this is false, if what's false? Well, our first condition is are we player 1? Okay, so if we're not player 1, then we just want to carry the forward score. Got a little lost there for a second. Uh-oh. Too many parentheses. It's not good. Let's debug this. Index s equals 1. So if that's true, then we're doing this whole thing. Oh. Nope. We need to close out here. There we go. So that's player 1 score. Let's double check that. So player 1 scores a match here. There's a lucky match, but it's not a match. There's a lucky symbol, but it's not the match. Gets 2 points here. Up until here, then doubles up at 4. Let's see if that's right. What's the example say? 5? What's the difference? I don't think we're right. Here, the alignment here is bugging me out. Here we go. So we're expecting, do we have these symbols right? We're supposed to have 3 matches when it doubles up. We get our players wrong maybe. Let's see what player 2 score would be. So we'll move this over and change. Where do we look for player 1? Player 2 now. Alright, so that seems fair. Match, that goes. Oh! Are we doubling before we add? We should add a plus index to 76. That should be that. So if we're 2, we should add 1 and double. It should be 6. Why isn't it working? First off, feels like we're only multiplying by the added amount. Yeah, because this parenthesis was a parenthesis issue. So now we close that out. There we go. So let's fix that here. And make this one 2. And then we'll say absolute value of take. Get a 1 minus take. Player 2 score. So, make this a data table. Okay, then we can say equals that. Good. Alright. Decent on time so far. Let's do a data table here. So equals x lookup. That's here and here. Nice simple lookup. Okay, so the player we want is value right player 2. Okay, and then our draw list will be splits text comma. So those are the cards we draw, and let's see. Come on, make this an X lookup and address and value. Okay, so for that we've got these. Okay, so we want to know, got a list of cards that we're supposed to know already. Well, at the beginning we don't know anything. So player 1 decides, and player 1 should play if they know a card. So let's see, knows match. So then player, let's see, card 1 gets played. This is just going to be the first one to begin with. Knows match. It's just hard coded for the first one. There'll be logic on the second one. Card 2. That's, you never need a match equals that, and then account these 2 cards. Okay, now our known cards would be if there's a match, then we'll substitute out the cards that we just used. So substitute that for empty, and if there's not a match, then it's going to be concatenating the 3 cards. Okay, since this was a match to begin with, there's no card still known yet. That's fine. Alright, so now, do we know match? Now we can possibly have known a match. Well, what will it be? So equals, and this, if that equals 1, then we won't know a match. But if it equals 0, we have the possibility. So if that equals 0, and we can find this last value in the known ones from before, then that is sufficient. Alright, so if we know, then we're going to pick that last one for sure. Otherwise, we're going to go back to our draw pile. So it'll be index of that, account plus 1. Alright, now, same logic here. Knows match. So we would say equals is number finds. Here. And so equals if that, then the first card. Otherwise, we're back to drawing from the index, and this will be account plus 2. So now here the count logic needs to change, so we'll say previous count is if we knew a match before, then nothing. We didn't draw. If we knew a match the second time, then 1, otherwise 2. Okay, and then from here, let's see what we did wrong here. Card 1. Oh, this is just references. Need to anchor this. And I need to anchor this. There we go. Now we get through our whole draw list up to here, and then after that it's errors. So we want to preserve the match column. Alright, and then the last thing we need to know is the player number. We didn't put any players earlier because the logic was such that it just alternates. So we can just mod 2, add back 1. So that's our player number. And copy all that. And here we're going to want to know sum if basically. Sum if player matches this player and is a match or not. So example matches, make it a data table. And check our answers. Okay, all good. Alright, bonuses. Which symbol only has one matching pair? So this will do a group by on all the values of the map. Count A, and we'll sort it low, small to big, and then take the first symbol. And we got that wrong. Extra comma here. There we go. Which symbol never gets matched across all level 3 games? Okay, so let's see the game. Level 3, here's all your inputs. So we can just to-row that and then wrap calls like before. Nice. So we go by call, M to C. So if index C1 equals index C2 and give me either value, doesn't matter. Otherwise, A. And then we can filter all of that out with the to call. So that's a list of symbols that do get matched. And so there's one symbol that doesn't get matched. So it's going to be what? Unique? Filter unique? I think it would be unique to call map. And then we'll say that will never be found in this list that we just created. So is an A X match unique to call map. So then we get a pizza slice. Okay. Which symbol would you encounter for the first time last if you went through the grid? Okay. So I guess again we'll map. What will we do? We want the actual symbol. I'm gonna need to like group by. It'd be easier if we just wanted the maximum, but okay, so let's group by, we'll say M value, and then we'll map M value lambda v, and then do an X match to see which row we find it in. So V and M row. That's not right. M value will return the row. This X match will return the row. So that's our map. Take the max in. Doesn't matter. It should be the same value. Now, what sort order do we want? We want low, high to low. Okay, so that's our group by. Take the first value, index 1,1. There we go. Alright, how many matching pairs can be found if you remove every other column? Okay, so we've done problems similar like this before. So we're just going to get all the symbols together. This is very much like level 5 or 6. 5. So first thing to do is filter M value, where M, let's see, map M call is odd. So that's just the odd column values, and then say let TB that, and we'll another group by T count A 0 0. That's all we need. So that should give us a table. we'll take the second column, and then do quotient 2 to get the count of the pairs and sum that up. 214 matching pairs. Alright, how many frogs did player 1 collect across all level 7 games? So going back down to level 7, we need a column to figure out how many frog matches by player 1. So that would be equals, if error, we're going to say player has to be 1 times, has to be a match, and then times the symbol has to be a frog. Let's see a frog here. Let's find the frog here. There's the error 0. Okay, now to our data table, we'll say equals sum that, and then expand to the definition of the data table, and sum down here 88. Alright, and that's how you solve the case with no lambdas. Thanks for watching. I'm Excel Gladiator, and my goal in making these videos is to help people level up their Excel skills, as well as to grow the world of Excel esports. If you want to help me do that, please like and subscribe, drop a comment below, or check out one of these other videos.